different type of routing. One is interior routing protocol, that is routing inside the autonomous system. Another one is exterior routing protocol, routing across the autonomous system. Okay. So in TCP/IP point of view, for interior routing protocol, we have WireSphere. For exterior routing protocol, we have BGP. I have not yet started WireSphere because it's something important. I'll take it into the topic later. Okay. So let's get into the exterior routing protocol. The one dominant exterior routing protocol is border gateway routing protocol. Okay, so it's based on two different type of messages. One is eBGP message, which is used to transmit the information about different autonomous systems. Okay, iBGP messages, it is used to transmit the information about the autonomous system inside a particular autonomous system. So iBGP and eBGP. And BGP, its main goal is not at least cost routes. Okay, main goal is policy-based routing. Okay, so main important goal of some time, because that's why in BGP point of view we have two common terminology like hot potato routing and cold potato routing. In some PGP protocols are implemented with hot potato routing. Some PGP protocols are implemented with a cold potato routing. Okay, so in hot potato routing, you don't worry about the least cost route. Okay, just transmit the packet to the nearest autonomous system without worrying about the least cost route to reach one autonomous system to another autonomous system. But versus the cold potato routing is the opposite of hot potato routing. Cold potato routing, it also deals with the way in which the particular destination autonomous system to be reached the shortest route. Okay, so I will show you those things also. Because hot potato routing, cold potato routing is not interior routing protocol. Okay, something related to exterior routing protocol or PGP routing protocol. Yeah, I think we started discussing about this particular slide, I think so. Okay, so in this case, we have autonomous system 1, 2, 3. Okay, and one of the router here 1C router is connected with the 2A router. Okay, as I said already, 1C router is a gateway router to reach S2, gateway router of autonomous system 1. Similarly, 2A and 2C are gateway routers of autonomous system 2. Okay, normally gateway router for the particular organization, if you take Shastra University, we have the gateway router. The gateway router is installed with NAT, DHCP, and DHCP and all those things. But what is the role of the gateway router? The gateway router, whenever it gets the packet from the outside world, it verify the packet payload. If it is based on the policy of the organization, the packet will be accepted. Okay. Otherwise, the packet won't be accepted. So once it is accepted, it will be forwarded to the appropriate destination. Similarly, each and every outgoing packet is also validated by using gateway routing protocol. Okay. So gateway routing protocol mainly deals with the policy related packet. So here 1C, 2A, 2C, 2A, all these are gateway router that is responsible for eBGP messages. Okay, but inside the router is also need to transmit the PGP messages. So all other router inside the autonomous system need to transmit that messages across the inside the autonomous system. That is based on iBGP protocol. Okay, so 1C, 2A, 2C, 3A. Okay, it will execute eBGP protocol. Okay, and all these routers also execute iBGP protocol, but iBGP protocol to be implemented, to be the messages to be executed by all the router in the same autonomous system. Okay, I'll show you with example. I said that WireSphere for RIP, each and every packet to be forwarded to the appropriate destination based on longest prefix match. Okay, so here also it is based on longest prefix match. But reachability is not based on the destination router. The reachability is based on the sub network. Okay. So in this case, this autonomous system is one sub network. Okay. And this autonomous system 2 is another sub network. Autonomous system 3, third sub network. Okay. So the role of BGP protocol, each and every gateway router of the different autonomous systems should maintain a forwarding table. Okay. 1C should maintain a forwarding table. 2A should maintain a forwarding table. 2C should maintain a forwarding table. 3A should maintain a forwarding table. Okay. So the forwarding table contains one entry for each and every other sub network or other autonomous system in the entire network. In this case, we have 3 autonomous systems. So 1C should have entry related to PGP protocol. It should have entry 3 entry. Okay. One entry, the way to reach S2. Okay. One entry, the way to reach S3. Another entry, the way to reach S7. Okay. So each and every gateway router should identify the path to reach each and every other subnet or other gateway router belongs to different autonomous system. Okay, so OSPF protocol or GRIP protocol, each and every router will maintain a forwarding table. In that forwarding table, it just add an entry to reach each and every other router in the entire autonomous system. For example, if you take AS1, autonomous system 1, if OSPF protocol, if it is executed by this autonomous system 1, 1A, 1B, 1C, 1D, it will have 4 entries. Okay, each and every forwarding table will maintain 4 entries. Okay, so 1A, it should have an entry to reach itself, entry to reach 1B, entry that is path to reach 1D, path to reach 1C. So, in the OSPF point of view, each and every router should know the cost to reach or route to reach each and every other router in the entire autonomous system. But border gateway protocol point of view, border gateway routing protocol point of view, each and every gateway router should maintain an entry to reach each and every other autonomous system. That's it. Okay. So yesterday I did some subnetting here. For example, if AS2, if it is denoted by, if it is represented by the subnetwork 14.1.12/28. Okay, so this subnetwork, okay, so this 1C should maintain an entry to reach this subnetwork. Okay, 14.1.12. But whatever may be the router inside the subnetwork, that are reachable from the gateway router. Okay, so whenever it gets the packet, for example, 1C gets a packet. Okay, so the packet is based on IPv4 packet. Okay, so the IPv4 packet is having 4 components. Okay, 4 8-bit compartment. Okay, so if, for example, it has a forwarding table, the first forwarding table is to reach AS2. What is AS2? AS2 is represented by the subnet. Okay, subnet mask. That is 14.1.12.12/28. Okay, and which link to be used? If the prefix is matched with this entry, then this interface to be used. Okay, let it be this interface is just interface 1. Okay, so whenever it gets the packet from this route or this route or this route, okay, after receiving the packet, it will just match the first 28 bits, okay, with this entry. Okay, 14.1.12. If the first 28 bit matched with this entry, it will simply forward the packet to this particular route. Okay, so similarly, 1C will also maintain another entry for AS3. AS3 maybe its subnet mask maybe 168.15.3.2/16. Okay, so if it is so, it may have the entry AS3 is something by 168.15.3.2. Okay, and which link to be used? For example, if there is a direct link like this, that link to be used. Otherwise, okay, this AS3 in this particular diagram, AS3 is reachable only through AS2. Okay, so whenever it gets the packet with the matching prefix of 168.15.3.2, again it will forward the packet to the same interface. Okay, now this router should also maintain an entry for AS1 as well as AS3. Okay, so if the prefix matches with this, it will forward the packet to this router through intra routing protocol, through OSPF routing protocol. Now after receiving the packet, 2C, again it will perform, 2C also maintain a forwarding table. Okay, if the prefix matched with 168.15.3.2, it will be forwarded to this interface. Okay, so after reaching this, automatically it will reach the appropriate router. Okay, so forwarding table point of view, normally OSPF routing protocol, that is interior routing protocol, OSPF, interior routing protocol, or PGP, border gateway routing protocol, PGP, border gateway routing protocol. The forwarding table structure remains same. There is no change in that. Okay, forwarding table, it will have 2 entry, only 2 entry, not least cast and all those kind of things. So the first one is in OSPF point of view, the first one is all other router in the network, and the next how, which link to be used, okay, which outgoing link to be used, which interface to be used. Okay, so for example, if you take AS1, 1A router, okay, 1A, it will maintain an entry for 1A, 1B, 1C, 1D, and so on to reach 1A, same loop. to reach 1B, interface 1, for example, if it is interface 1 to be used, to reach 1C, interface 1 to be used, and to reach 1D, interface 2 to be used. Okay, so this is for the forwarding table based on OSPF algorithm for router 1A. Okay, but if you take PGP, the gateway router to be installed with the forwarding table. Okay, so 1C will be installed with, okay, 1C will have the forwarding table. Okay, so 1C gateway router to be installed with the forwarding table with again 2 and 3. One is all the routers and subnetwork or autonomous system. Okay, so a similar entry will also be available. 1A, how to reach 1A, how to reach 1B, how to reach 1C, how to reach 1D. Okay, this is a result of OSPF routing algorithm. But in addition to that, it will have some more entry as a result of a PGP algorithm. Okay, so what is that? Autonomous system 2. Okay, autonomous system 3. Okay, so to reach autonomous system 2, autonomous system 2, 3 also represented by in terms of IP address. Okay, longest prefix matching. So AS2, to reach AS2, which link to be used? Okay, to reach AS3, which interface to be used? Okay? So as a result of PGP, PGP is not a standalone routing protocol. It works with a joint effect of OSPF. Okay, internally to route the IPGP packet, OSPF routing protocol to be used. Okay, so by exchanging IPGP packets, these entry will be filled. Okay, IPGP packet, this entry will be filled. IPGP is exactly like OSPF. Okay, and by executing ePGP, these entries will be filled. Okay, so we'll see how these entries will be filled. Okay, so whenever you design the forwarding table, whenever the PGP protocol is executed, the forwarding table to be constructed in the gateway router by making one entry for each and every other autonomous system. Minimum one entry. There may be more than one entry also. Say for example, if 1C is connected with the 3A, then there may be more than one entry. To reach AS3, one route is 1C to 3A path, another one indirectly to AS2 you can reach. Okay. If there are more than one entry, again, which particular route to be selected for the forwarding table based on number of hops, not least cost route, number of in-between links. Okay. So in this case, this is a direct link. So that link will be used, that interface to be used to reach AS3. Okay. So border gateway routing protocol is not based on least cost route. Okay. Border-based gateway routing protocol is based on the policy and the directly connected autonomous system. Okay, so which autonomous system is reachable? Okay, reachability. Okay, reachability in terms of how fast it is reachable. Okay, how fast it is reachable is based on number of links. Okay, so that is the idea here. Let's see how these messages are exchanged. Okay, BGP protocol, OSPF. The packets, link state packets are transmitted in terms of UDP datagram, okay, ICMP datagram. But here PGP is a application layer protocol, not network layer protocol. Okay, so whenever two peers exchanges the data, definitely that should be the connection transport. Okay, so it is based on one type of connection called semi-permanent TCP connection. Okay. What is it? Semi-permanent TCP connection. You know, permanent, persistent TCP connection, permanent TCP connection. Okay. So semi-permanent TCP connection means the peer establish the handshake protocol and two peers execute the handshake protocol to establish the connection. Okay. The connection will be alive as long as there is an exchange of messages. Okay. If there is no exchange of messages, automatically there is a timer called keep alive timer. Once there is no messages between two peers during the period of keep alive time, automatically the connection will be disconnected. So the TCP connection is not permanent, semi-permanent. As long as there is a messages or updates between the two peers, then the connection is retained. Okay, otherwise connection automatically disconnect. Okay, that's a TCP connection. It's not persistent connection; it's a permanent, semi-permanent TCP connection. Okay, so PGP, see this may be some common thing because we are dealing with the network layer. Okay, so network layer, the type of packet to be transmitted across the router should be only ICMP packet or IP data. Okay, but PGP is not a network layer protocol. PGP is an application layer protocol. So we have to establish the TCP connection between two gateway routers. Gateway routers are computing devices and edge terminal. Okay, so two PGP router. In this case, the peers or edge terminals are nothing but this. the gateway router. So 1C and 2A, two peers. Okay. So 1C and 2A to exchange messages. First of all, it should establish a TCP connection. Okay, handshake protocol to be executed. The other router should accept the connection. That's why here, for example, if the particular country is having a different policy, if, for example, if the country, this AS2 belongs to one particular country, AS1 belongs to some other country, and this based on the policy of AS2, the packet from AS1 may not be accepted. Okay, so that TCP connection never be accepted. It won't accept the TCP connection at all. So this link never happen, never be used at all. So first of all, two PGP routers, two peers establish the PGP messages. I'll tell you what is the format of PGP messages to establish a connection. Okay, connection messages are something different. So by using that TCP connection to be established. Okay, so through this TCP connection, exchanges the messages. Okay, but what type of messages to be exchanged? That is nothing but advertisement messages, advertising the path. Okay, see, as like link state routing protocol, OSPF routing protocol. Remember, each and every router first construct a link state packet based on the information from the neighboring router and all other router, and then link state packet to be broadcasted to all other router. Okay, that is nothing but advertising about the topology. Similarly, this gateway router should advertise the existence of itself. Okay, so existence of this autonomous system to be advertised. I will tell you with example. I think here itself I have an example here, small example. Okay, because this diagram I need. Okay, let me take it out. Okay. See, in the autonomous system 3, one new router is added. Okay, that is X. Okay, so what will happen to that? Once a new router is added, all the autonomous systems should maintain an entry to verify the reachability of that router. Okay, see how that happens. Once the router is added onto the autonomous system 3, okay, now the autonomous system 3 is having the route to reach X. Okay, X is no more unreachable, it is reachable, okay, from AS3. Okay, so once the new router is installed, the gateway router of this autonomous system, AS3, gateway router is 3A, it advertise the path to reach X. Okay, so the PGP, eBGP messages to be exchanged. 3A to 2C, all the messages are eBGP messages. 2A to 1C, all the messages are eBGP messages. But inside 1A, 1B, 1C, the messages are iBGP messages. Okay, the message format is different. The message format includes two things. One is the subnet, the autonomous system in terms of subnet. Okay, subnet mask of this autonomous system. AS3 or subnet mask AS3. If, for example, if it is belongs to 168.1.12/16, and this will be 168.1.12.16. So AS3 is nothing but this particular autonomous system subnet mask. Come on. The X is reachable. Okay, X is added onto the autonomous system. So which particular router is reachable? X is reachable. Okay, so that is advertised to 2C. Okay, so 3A, you can ask one question, right? How does 3A knows that the existence of X, because X is attached directly to 3D. Okay, so how does it know? 3A gateway router, how the particular router 3A knows about the existence or addition of the new router into this autonomous system. That is based on interior routing protocol. Okay, so as a part of OSPF routing protocol, interior routing protocol, each and every router knows about all the routers. Okay, so 3A, definitely it will have a new entry in the OSPF forwarding table to reach X. Whenever there is a new entry in the OSPF forwarding table, automatically it will advertise that existence to the other autonomous system. Okay, now 3A just transmit the packet to 2C. But here, only one link, the gateway router is attached with only one link, 2C. If 3 is added, for example, if I have the link like this, for example, because advertisement is a broadcasting message, it's not a point-to-point message. Okay, if it is connected like this, for example, if there is a link like this, then 3A establish the TCP connection. It's just open one TCP connection with the 2C, another TCP connection with 1C, and it will send this messages to 2C as well as 1C. What is the message? We have two entry. The first entry is the autonomous system reachable, and the second entry is a nested hop router. Okay. Now, after receiving this information, 2C should advertise this information to 2E. Okay. So now here the message is. Okay. So before that, let me get into this diagram. Okay. See, AS3 just transmit the ePGP message to 2C. That means it advertises the route to reach X through this message. Okay. Then after receiving this message, 2C knows the way to reach S. Okay. So that information to be transmitted to all other router by using internal routing protocol, by using OSPF routing protocol, and that message is IPGP message. Okay. So 2C. And here one point is, as I said already, PGP protocols are based on policy. Okay. If AS3, autonomous system 3, routing through autonomous system 3, if it is accepted by AS2, this advertisement will be accepted. Otherwise, it won't accept the advertisement. Accepting the advertisement means once it is accepted, it should be reflected in the forwarding table and it should be forwarded to the next gateway router. Okay. So if the policy of AS2, if the policy of the AS2 denied the routing through this autonomous system 3, okay, if it is so, then it won't accept this advertisement. Okay. So PGP protocol point of view, the policy is a very important factor. Okay. So once a policy, what is the policy here? If AS2 packets, if it is allowed to transmit or route the packet through AS3, then this message will be accepted. Okay. This message 3A to 2C message is ePGP message. Okay. ePGP message. After receiving this, if the policy of AS2 allows the routing through AS3, it accepts the packet, and that route is reflected in all other router in the same autonomous system by means of internal PGP messages as a part of OSPF protocol. Okay. Now here 2A knows that X is reachable through this router. Okay. Now see, this is a new advertisement. AS3, X is a newly created advertisement by 3A. Okay. Then after receiving this advertisement, AS2 should also inform this matter to AS1. Okay. In that case, when it sends this advertisement, AS3's advertisement, it should add its own subnet address also. Okay. See the message. This is slightly different. So when it transmits this advertisement to its nearest neighbor, okay, it also had its own subnet address. What is the meaning of this? X is reachable through the autonomous system AS2 as well as autonomous system AS3. Okay. Why? What is the reason for this? Now, say in AS1 point of view, if it hides this, okay, AS2 is reachable through this 2C. Okay, it can send the message like this. But what will happen? Actually, the packet passes through 2A, 2C, and then AS3 also. But AS1 point of view, AS3 may be the prohibited range. Okay, prevented region. The routing should not, the AS1 packet should not be forwarded in AS3. Okay, so that may not be known to AS1 if it is removed. Okay, so when the packet, when the route is advertised, autonomous system adds all the reverse path also. Okay, so AS2, AS3, X. Once after receiving this message, AS1 gateway router decides whether it is accepted or not. If AS2 as well as AS3, or if these two autonomous systems are compatible autonomous system or accepted autonomous system, then it allows this message, accept the message. Okay. Once the message is accepted, that will be reflected in all these routers. Okay. So got it? In OSPF protocol, each and every router need not worry about in-between links. Okay. But in border gateway routing point of view, each and every gateway router need to worry about in-between autonomous system. Okay. So for example, this may be the packets belongs to, IP packet belongs to US. This may be the IP packet belongs to UK. And this may be the IP packet that belongs to some hidden or a prohibited region as part of as a policy, as based on the policy of US. Okay, this may be a North Korean subnetwork, okay, a Chinese subnetwork. So when it passes through this, A3 may be accepted, A2 may not be accepted. Okay, if A2 is not accepted, then definitely the packet is not reachable to A3. Okay, so that is the idea here. But see, in internet point of view, the subnetwork is not based on one-to-one connection. Okay, there may be some other route without AS2. There may be some other route to reach 3A directly. Okay, so if this autonomous system is a prevented region of or prohibited region of AS1, the packet may be forwarded directly to 3, irrespective of the delay and in between links. Okay, so in between there may be 3 autonomous systems. Okay, if 3 autonomous systems policies are accepted, then the packet may be forwarded through this route instead of this. But as far as the least cost point of view, this route is a least cost route. AS1, AS2, AS3 is a least cost route. Okay, but AS1, AS4, AS5, AS3 is not a least cost route. But PGP not based on the least cost route, it is based on policy packet. That's why it is known as hard potato routing. The least cost route may not be used if the policy not matched with the compatible autonomous system. Okay, so that case is known as hard potato routing. Okay, and another thing, there may be more than one route. Okay, so here in the 1C router is a multi-home router. Okay, 3A is a multi-home router because it has two different link to reach different autonomous systems. Okay, now in this case, I said already. So now here, if you take it out this particular architecture, the existence of X. Okay, existence of X. So existence of X, 3A just to transmit the existence of X to this gateway router as well as this gateway router. Okay, so AS3, X. Okay, now this 2C receives two messages. Okay, for reachability of X. One is AS2, AS3, and another route is AS3. Okay, so it decides this route. If it is a OSPF routing protocol, the best route is based on number of in-between hops. Okay, now here it will decide the best route based on the policy as well as number of in-between hops. Okay, if the policy of A3 is accepted and this route will be accepted. Okay, now it will make an entry in the forwarding table, the reachability of X to AS3. So directly, whenever it gets the packet will be forwarded to this particular link directly to reach X. Okay. So if there is more than one path, the appropriate path to be selected based on policy first and then least cost. Least cost means number of in-between links. Yeah. Okay, not based on delay. Number of in-between links. Nearest connected autonomous system to be used. Okay. Okay. So let's say one more thing. Okay. So ePGP messages, I said ePGP messages to be exchanged between 3A and 2C, and iPGP messages to be exchanged between in between router. What is that message? What are the informations are available with that message? Okay, it will have information like a path attribute and PGP route information. Okay, so the path attributes it contains two things. Okay, the longest prefix match, that means if it is if the subnet mask is 168.1.12.1, that is the longest matching prefix. Okay, longest matching prefix, otherwise you can put the word subnet. Subnet is something but the longest prefix. Okay, so this longest prefix as well as it also have attributes. Okay, so the longest prefix is nothing but, for example, if the particular router AS3 advertise the route to reach X, so then the longest prefix is nothing but AS3's IP address, okay, subnet route address. And then the same thing is forwarded to AS2. AS2 will send AS3's address and AS2's address. So the prefix is nothing but subnet address. But in addition to that, it should add two important properties, two attributes. What are those? The first attribute is nothing but a next hop, okay, which link to be used. Okay, internal router point of view, which link to be used. Okay, in this case, see here, 2A, okay, so 2A point of view, it should have the forwarding table to reach autonomous system 3, which then to use this interface, okay. So the next hop router is there, which in between, which connect the router to be used to transmit the packet. Okay, that next hop router to be decided based on OSPF routing protocol, that is IPGP protocol, okay. So that is next hop router to reach autonomous system. And another thing is that path. The path includes just consecutive AS, autonomous system. If AS3 advertises itself, advertises the existence of X, then it will have only one entry. Okay. If AS3's advertisement is forwarded by AS2, then it includes AS3's address, some network address, and AS2's address. Okay. So the prefix advertisement to be added. So autonomous system path is one property, and which next internal router to be used to reach the autonomous system. That is the next important property. Okay. So whenever the PGP messages are exchanged, ePGP messages or iPGP messages, just it sends the path attribute. Okay. So the path attributes includes all those things. Okay. It's not like a link state pattern. Okay. It won't include any cost pattern. The cost to reach, a delay or load. So those things never be added. Okay. As I said repeatedly, it's based on policy-based routing. Whenever the node advertises itself, the most important thing is that policy, whether the particular path is accepted or not. That is decided by the autonomous system. Okay. So once the policy is decided, then it will advertise its path to nearest autonomous system. Okay. Otherwise, it won't advertise the path to the other autonomous system. It won't accept the path also. Okay. So I think this is the difference. Okay, so this is multi-path autonomous system. If there is more than one path, the path will be decided based on the policy as well as number of in-between links. Okay, this is an example for hard potato routing. Okay, so based on the policy, the messages to be expressed. So the PGP messages is based on the TCP connection. Okay, there are 4 different type of PGP messages are possible. Once the new router is added, okay, so if it wants to advertise its existence to other autonomous systems, then it will send an open message. Okay, so open message just to simply create a TCP connection to the remote peer entity. So only one-to-one connection is possible. So for example, a autonomous system 3 need to advertise its existence of X to AS2 as well as AS. One means 2 TCP connection to be established. Okay, open message to be transmitted to AS1 as well as AS2. Okay, and the new path to be advertised by sending the message called update message. Okay, so update message automatically includes time to live. Okay, so the updated message, if the particular router receives more than one updates from the autonomous system, from the gateway router, it will accept the updates with the latest timestamp value. Okay, so it includes timestamp value. Another thing, for example, AS1 gateway router, AS2 gateway router, this is connected by using a TCP. TCP is not a physical connection. TCP is a virtual connection. Okay, so the TCP connection is to send and receive the messages. Okay, so once the TCP connection is established, it will send the updates. Whatever the updates is, because it may be connected with few more AS, autonomous system. Okay, so whatever the updates it receives, that will be transmitted. Okay, so once after transmitted, that messages simply exits either. Okay, it won't send anything. Okay, so the receiver will send the keep alive message. Okay, so if there is a silent band for some period of time, automatically it sends a keep alive message. Okay, so if in the response to the keep alive message, if it has something to send, then it will send the update message. Otherwise, it will send the acknowledgement message to maintain the connection. Okay, so the keep alive is used to verify whether the peer entity is alive. Okay, or it has some updates to transmit. Okay, notification is just for error messages. Whenever you get some error messages or the error in terms of TCP point of view, error is something that they're not matching internet checks. So if it is so, simply report the message and proceed. Okay, so these are the different type of messages which are exchanged in PGP routing protocol. Open, it is used to create a new TCP connection, but there is no closed method. That's why it is called a semi-permanent connection. There is no closed message. Okay, if there is no updates, automatically keep alive message will be transmitted. For that, it may send acknowledgement or may not send acknowledgement. If there is no acknowledgement, automatically connection will be disconnected. Okay, if there is no updates, automatically connection will be disconnected in response to keep alive message. Okay, there is no close message. That's why it is called semi-permanent. Okay. And this is what the real idea about hard potato versus cold potato. Hard potato. And we have two different concepts: hard potato as well as cold potato. See, in this case, the autonomous system 1, I have 4 routers: 1A, 1B, 1C, 1D. Okay, and this 3A advertise the route to reach X to C as well as to 1C. Okay, so now here 1C it has 2 routes to reach 3A. Directly to 3A, that is AS3, X, that is one route. Another route is AS2, AS3. Okay, so now here in this particular autonomous system, 1A, 1B, 1C, 1D, all these routers knows the route to reach X through this 1C. Okay, so 1C, after receiving this, it decides this route or this route based on the policy. Okay, if it selects this route, then it advises this AS3, X to 1B, X3, X to 1D, X3, X to 1D. So all the routers, all other gateway router, all other router except the gateway router identifies the route to reach X through IPGP messages from 1C. Okay, so here IPGP message is AS3. Okay, so in this case, how the particular routing table to be updated by 1A. Okay, so 1A has this link and this link. Okay, this link is numbered as interface 1, and 1A to 1D link is numbered as interface 2. Okay, it has 2 interfaces. Okay, so now see the forwarding table. The part of the forwarding table of 1D to reach 1C. This is a result of OSPF routing protocol. Okay, to reach 1C, this interface to be used. Okay, so destination, if the destination is 1C, the interface to be used is 1. Okay, if the destination is X, what is the interface? What should be the interface? In ID 1D, what should be the interface to be used? If the destination is X, after receiving this AS3, X, what will be the entry here? Any guess?
1.
1 only. So this is a result of OSPF protocol, and this is a result of PGP protocol. Okay, so now I have automatic. So X, 1. So X, 1 is a result of PGP protocol. 1C, 1 is a result of OSPF protocol. Similarly, we get into the forwarding table of 1D. Okay, 1A, 1B, 1D are non gateway router. Okay, it's not a gateway router, internal routers. Okay, now see what will be the forwarding table of 1C is reachable through this interface. Let us take this is a result of OSPF routing protocol. Okay, this is also reachable and this path is also possible. But here, let us assume this is a least cost approach based on OSPF. Okay, so 1C is reachable through. Similarly, it also add after getting the advertised right, it also add one more entry. What is the entry? X is reachable through this too. Okay, so whenever it gets the packet, belongs to the whenever it gets the packet with the destination IP address of X, the packet will be forwarded to 1D. Okay, it will reach 1D. 1D is also having the forwarding table. Okay, X with the interface 1. So in this interface, it forward the packet. From 1C, it will be forwarded to this 3A. From 3A, it is forwarded to X based on internal routing protocol. Okay, so this is the case here. And I have not yet discussed about hard potato routing. I'll tell you. Inter and intra, why do we have 2 different type of routing? Okay. In the global perspective, you can again get into the OSPF routing protocol. Then what is the purpose of having a separate protocol for inter-autonomous system routing? Okay. So the reason is that the policy inside the autonomous system, most of the as a security person. They can classify the attacks into 2 types. One is insider attack, another one is external attack. Okay, intruder attack. If you take any organization for bank, okay, if you take one bank application or bank organization, the attack launched by the internal persons are very minimum as compared to external person. Okay, so Reserve Bank of India or SBI, the target of flow system is from the external point of view, external intruder. Okay, so there may be some policy to prevent the external attack. Okay, each and every autonomous system that should have some perimeter security. Okay, so for that perimeter security, we have the policy. So the policy to be included or incorporated inside the autonomous system whenever it sends the packet outside the autonomous system, as well as it gets the packet from outside autonomous system, some policy to be added. Okay, but internal to the autonomous system, if you take universities, Shastra University, whenever we transmit the packet, the policy is not a matter. Okay, all the person belongs to the same organization. So whenever they enter into that organization, they accepted the policy and they also know the way in which the system to be used. So internal point of view, what is the demanding requirement? The quality of service. That means low delay, low load. Okay, so internal transition, it requires different policy. External transition requires different policy. That's why we have two different type of routing. Another thing, internet is a heterogeneous network. We have different collections of network. Okay, so only this hierarchical routing, it reduces the number of entry in the forwarding table. So in this case, if you take this AS1, each and every router should maintain only 4 entry. Okay, each and every only maintain only 4 entry and 2 more entry to reach other autonomous system. Altogether, it will be 4 plus 2, only 6 entry. Each and every router in AS1 should have 6 entry. Okay. Similarly, AS2, it has 4 routers, so each and every router should maintain 1 entry to reach other router and 1 entry to reach other autonomous system. So 4 plus 2, 6 entries. But here we have divided the network into 3 different hierarchies. Okay, so if there is no hierarchy, or if there is no hierarchical routing, what will happen? 4 plus 4, 8 plus 5, so 13. So 13 routers are available. So each and every router should maintain 13 entries. Okay, so in this case, we have taken a Tor example. Okay, but in the real sense, each and every autonomous system is having thousands of routers. Altogether, handling the global internet is not possible. Number of entries in the routing table will be very, very high. So dealing with a large number of entries also time critical elements. Okay, so that's why we are having the different type of routing protocol: interior, inter, and intra. Interior versus exterior. Okay, so handling a very large thing is something important. So inter AS point of view, the performance is a invocation of policy. That's it. For inter routing protocol point of view, OSPF or RIP protocol point of view, the performance is something but least cost or low delay, okay, or low load. So intra AS, the performance factor is the least cost. For inter AS, the performance is based on the policy. Performance is not at all a matter. Okay, so the policy to be incorporated generally because PGP point of view, because more work are going on with the PGP protocol, because security is playing a vital role. When we transmit the packet, because if you take Sweden, hacking is an allowed one. Okay, but in India, if you want to perform hacking, then you have to get the approval from the concerned organization. Ethical hacking is not allowed. Okay, so in some countries, different policies are there. So one country's policy may not be, because if in particular country, if hacking is allowed, the people can launch the packet by using some, but those packets never be accepted by the country which prevents hacking. Okay, so each and every country is having a different policy. So security playing an important role. So PGP point of view, the policy factor to be incorporated properly. Okay, so then only the secure transmission is possible. Secure routing is possible. So this is impact of border gateway routing protocol. The impact or side effect of border gateway routing protocol, that is known as hard potato routing. What is the hard potato routing? See, here the same architecture I have taken, AS1, AS2, AS3. AS3 is 3A, X is reachable, 3A is reachable through 2C. Okay, and 2A can reach 3A from 2A to 2D, and then 2D to 2C, and then 3. Okay, so previously from 2D to 2C cast. Okay, let me take 2D to 2C cast. Previously, it is, let me take it as very small. 4. Okay, so here whenever the packet targeted on autonomous system 3, okay, so AS3 advertises its route to reach X, okay, X3 is transmitted here. Now 2C learns that it can reach X through this 3A, so that entry will be transmitted to all other router through this internal routing protocol. So 2D knows that it can reach 2C, sorry, it can reach X through 2C or with 2A. Okay, so if you reach panna, this is one route, another route is this. Okay, so now here, hard potato routing, the local gateway that has least intra-domain cost. Okay, in this case, AS3 is reachable in this route. In that case, the cost is 201. Okay, and AS3 is reachable, X is reachable through this link, the cost is 263. Okay, so now 2D has to make the decision. Okay, it has the packets with the destination address X. Okay, so for example, it may be connected with some node host directly. See 2D. 2D is connected with some host directly. It just sends the packet X with the destination address X. Okay, now that packet to be routed from 2D. Okay, whether this path to be selected or this path to be selected, there is that decision to be taken. Okay, if it is OSP of routing protocol for internal, if X belongs to the same autonomous system, then definitely it will select the packet based on the least cost routes. Okay, but this X is not belongs to the same autonomous system. Then what will be the path? Okay, so 2D will select 2A, even though the autonomous system here, it should pass us through 2 autonomous system to reach X. Okay, so the path is from 2D, it should be transmitted to 2A, and then it is transmitted to 1C, and then it should be transmitted to 3A, and then some internal routing X. Okay, now see number of links 1, 2, 3, 4, 5. So number of hops here 1. Okay, but if it chooses this 2D transmitted to 2C and then 3A, then it will reach 3D, then X. Okay, so here number of in between links 1, 2, 3, 4. Okay, number of hops here 4. So the hard potato routing, the in between links, okay, it won't worry about the complete path to reach the destination address. Okay, so just it make the local decision based on the outlink capacity. Okay, this is hard potato routing. Okay, it's a reverse one is cold potato routing. The cold potato routing, the 2D router decides the route to reach X based on the reachability of AS3. Okay, AS3 is reachable only through 2C. Okay, so the reachability of AS3 is somewhat fast, or number of links are limited. So that if it is cold potato routing, the route to be selected will be 2D, 2C, 3A, and X. Okay, by default is hard potato routing. But you can ask one question. Boundary gateway routing protocol is based on both hard potato routing and cold potato routing. When do we select cold potato routing? Okay, we have a scenario here. So that going to be selected if the particular subnetwork belongs to the different ISPs, different internet service providers. Because internet service providers are third party or authorization based on the number of customers. Its reputation is based on the number of customers. Okay. So normally ISP, internet service provider, wants the traffic to and from its own customer. Okay, only inside its network. Okay, so for example, Jio customer, Jio network, it may expect a customer to use its own networks. Okay, so let's say an example here: A, B, C. A is one internet service provider, B is another internet service provider, C is another internet service provider. Okay. Now W is a new router added with A. Okay. So now it will advertise this information to B as well as to C. Okay. Now here we have the link. Okay. So B needs to advertise this route to C. Okay. But if B belongs to the different internet service provider and C belongs to a different internet service provider, then B won't advertise that route to C. Okay. So why? X is a direct customer of B. Okay, Y is the direct customer of C. Okay, so if this route is a least cost route, okay, Y packet may be forwarded through B also. Okay, So never allows ISP-C never allows its own customer to use other internet service providers network. Okay, so what will happen? Just A advise its path to B as well as to C. Okay, A comma W to B, A comma W to C. Now here A won't advertise because A is a different internet service provider, C is a different internet service provider. W is reachable only through A. That's no doubt about it. Okay, but B's customer need not follow C route. C's customer need not follow B's route. Okay, that is what the thing. So B never advertise as well as C never advertise its new route to B as well as new route to C. Okay, so the reason is that it won't get revenue when the packet X packets are transmitted through CAW routes. Okay, if X packets are transmitted through BAW route, then we will get benefit out of it. Okay, so that is what the thing. So this is cold potato route. Okay, so here the route is decided based on the reachability of the autonomous system. Okay, in the previous case, hot potato routing, the route is decided based on the least cost route. Okay, so that's the thing here. C will route the packet through this. But here the idea is one more problem here is X is a multi-home network. Okay, the customer is having an account with the two different service providers, B as well as C. Then what will happen? Okay, X is a customer network. It's a multi-home network. Okay, ABCs are providers, and X, Y, W are customers. Okay, and typically the X belongs to two ISPs, multi-home network. Okay, so if it is so, what will be the policy? Okay, what will be the routing? So that is based on the policy. Okay, so X may not want to route the packet through from B to C through X. Okay, so in that case, this X won't advertise its new route to reach C from B. Okay, so that cold potato routing is because of two reasons. One is whenever there is a change in the policy factor, then the cold potato routing to be used. That is the nearest autonomous system which is reachable, that should be updated. Otherwise, if it is based on two different internet service providers, then we can decide the route based on the reachability of the internet service provider, not based on the other factor like the least cost and number of MBP forms. Okay, so this is what the policy related to the route advertisements. Okay, so whenever the route is selected, these four factors to be considered, but the first important point is policy. Once it is satisfied the policy, then only it will go ahead with the path. Okay, number of in between autonomous system, and then it will decide based on the next hop router. Additional criteria, security, privacy related criteria can also be added with the PGP routing for route selection. Okay, so that's all about border gateway routing protocol, one of the very common exterior routing protocol for transmitting the packet from one autonomous system to another autonomous system. Okay. So that's all about BGP. If you have any doubt, just you can ask me.